Hello everyone. So this is Kaushik here and welcome back. So in our previous discussion, we had a look at the containers. So basically we talked about virtual machines, the virtual machine model and server virtualization. And then we looked at the pros and cons of virtual machines and we basically looked at a better model of containerizing applications wherein you can package your application and their dependencies, and in that way you can isolate each container in a single virtual machine, so without needing multiple virtual machines or for that matter multiple physical machines for each different development environment. Now in this particular discussion, what we will do is we will have a look at how actually containerization works, I mean what makes it work, and then we will look at what are the tool sets available today and what's the most popular tool set. Of course, we know that Docker is the most popular container tool set. So we will look at Docker and how Docker works before we go into the next session where we will be doing hands-on lab with Docker. Okay, so let's get started. So the first thing that we are going to check over here is that how Dockers actually work. So the first thing which should come to your mind is that when we're talking about virtual machines, what was essentially the isolation model? So what we were actually isolating were the different processes that were being run. Now in a virtual machine model, each process is isolated from a different process which is running in a different virtual machine, although they were having the same server. But in a container model, we need to achieve the same process isolation. And how? That's the big question. If we are sharing the same host operating system for all our containers, then how would we be able to achieve process level isolation, which means that a process which is running for a container A has to be isolated from a process running in container B. However, they are actually running on top of the same operating system. So this isolation is possible because of something that was invented for Linux kernel. Okay, so Linux kernel has a very special feature which is called namespace and C groups. C groups as in control groups. So what are namespaces? First of all, namespaces should be pretty familiar with developers. So as developers, we deal with namespaces day in and day out. What that means is, if we talk about cout, we know that, or the system gets to know that we are actually talking about a specific namespace in this case. Or if we are talking about, let's say a thread, in that case the system knows that we are talking about system.threading namespace for that matter. So it's all about the context that is important to the system. So if we can imagine this to our day-to-day conversations that we have. For example, let's say we are talking about we are talking to somebody, and we are saying that the market didn't go well at all today. The market didn't go well at all today. Now, as human beings, what happens is that the audience to whom we say this automatically adjusts to the context. So he or she is able to understand that we are talking about the stock market most probably. And that's the context here. For example, if we are talking about, let's say, it was a great match. Now, if this is spoken to a sportsman, definitely the person would map it to a cricket match or a football match or any sort of game when we are talking about a match. However, if we are talking about, let's say, a matrimonial relation over here, then the meaning changes totally. It's a great match. So it's all about the context that makes people think that we are talking about that and only that thing. Which means that, let's say person A who is mapping this to a matrimonial relation does never even think of a cricket match. On the other hand, somebody who is actually mapping it to a soccer match doesn't even think of a possibility of a matrimonial relationship context over here. So the point I'm trying to make is the context, which is in this case our namespace, makes us close the scope. There may be 100 different contexts, but whenever we attach the context to our conversation, we forget about any other context for that particular conversation. As human beings, we do this implicitly. In IT or in a typical computer background, we have to do this explicitly. We have to make the computer know what context we are talking about, and that's the namespace here. So, namespaces are Linux kernel features that make the system isolate processes. Let's take a simple example. We all know that each process is identified by a process ID or PID. Now there is a namespace in Linux kernel which is called the PID namespace. Now what that means is, in a typical PID namespace, the parent process always assumes a process ID of 1, and the children, which is the processes are forked from that particular process, they become other processes, and all the other programs are totally gone. So processes running within the same namespace can definitely talk to each other. They are not isolated from each other. However, processes having different namespaces are definitely not able to communicate with each other, and they are isolated. So namespace, and in this case the PID namespace, enables us to have a boundary across processes.